Hey Jack, how you doing?
Hi, yeah, very good. Thank you very much. How are you?
Yeah, really good. Really fun to have you on the podcast. Like I feel like we haven't actually had any robotics entrepreneurs on the podcast before. That's why I'm so excited to have you on, and it's such an exciting field, I feel like, to be a part of. It's kind of surprising to me why I haven't had any entrepreneurs from the robotics space at all.
Mm.
But I mean, yeah, first time for everything. I feel like this might be a really good first time as well, like in the robotics space, because what you're doing with HouseBots seems like so exciting. It seems crazy exciting. So yeah, massive pleasure
Yes,
to have you on.
yeah, no problem. I guess the one of the reasons is that building robots can be very hard. So there's not many people as stupid as me. Um, but after this, I'll hook you up with some people that I know you can get even more guests on.
Yeah, of course. I think yeah, it's an industry obviously that's booming and exploding along with like some other industries that we've talked about before. But yeah, I think it's really cool. And I think before we move on to I guess how you started and I guess like why many people might not do robotics is quite hard. I think it'd be really good for people to find out like what is HouseBots, like what is it actually doing day to day. It's doing some really exciting stuff.
Sure. Yeah, so I'm Jack, CEO and co-founder of HouseBots. We have a vision for the future where humans' feet don't leave the floor when it comes to inspecting and maintaining buildings and infrastructure. Our first step on that vision is to build our first product, which is a wall climbing robot. It's a patent pending system, and the unique thing is that our robot can climb basically any type of surface, any type of wall, concrete, flat surface, render, rough, smooth, you name it, the robot can deal with it. And then adding different attachments on that for maintenance and inspection tasks. So we're kind of going a level up from what today's technology does, which is typically like visual based drones or things like that, and really adding physical tasks to robotics for inspecting and maintaining our infrastructure. We've raised somewhere around $1 million in total from funding from venture capital, some grant funding. We're a team of about seven now based in Birmingham, and we it to our first customers.
That's really cool. That's really cool. And I think it's like, yeah, as I said, it's such a cool space, but more than anything, like building sites and like maintenance of buildings and things like that, like there are quite a lot of deaths involved. Like it is a pretty messy job. So any sort of innovation within that space of trying to maintain, humans' feet on the floor, as you said, that's like a massive win.
Yeah, exactly. I mean, the problem is really threefold. The first side that you really touched on is the safety. I mean, it's actually the single most dangerous thing you can do in your career is working at height. There's more deaths in falls from height than for any other cause in the kind of Western world. Leading cause of deaths at work in both the UK and the US is people falling. So, danger
Wow.
definitely. The cost as well. Typically at over about 2 meters, if you've got an inspection or maintenance project, then you'll have to get proper access. And what I mean by proper access is typically something like scaffolding or a cherry picker or something like that, not just a ladder. And once you've got these involved, then about 50% of your project cost gets swallowed up by that access. So, let think that you're painting the outside of a pretty big building, then you could easily be hundreds of thousands of pounds deep in scaffolding. And then the third thing is the disruption that all of that stuff causes. Like it takes a lot of time to set up your scaffolding, to
Mm.
do all your risk assessments, to get your permits, to get your licenses, to do the job, to take the scaffolding down. But we kind of want to be in a position where you can turn it with a robot, stick it on the wall, and you can start your maintenance or inspection project immediately.
How good, this is a question I have with any like robotics project, is how good is the robot compared to a human? You must get this question all the time, right? Because it is like the magical question, because obviously like on videos and things, you might see some like Japanese robots doing some funny things. But as for like commercial use, like yeah, it's something that it's a bit of a like it's a space that I don't know if I've seen like too many things in. Obviously, like it's not my area, but I
Mm.
guess in terms of like comparisons to an actual human, like how how's the how like far has the innovation come basically?
Yeah, so obviously it depends massively on the task that you're doing. A lot of the things that we're doing are kind of carrying a sensor from A to B. So if I can paint a picture in your mind, there's a particular use case that we work on, which is ultrasonic thickness measurements of metallic structures. One of the typical structures is a storage tank that we might be working with the client on. Um, we take the sensor that would be in a person's hand and just stick it on the robot. And what this sensor does is that it drives, or in the human sense, they have to somehow get this sensor to be in contact with the side of the tank from the bottom to the top in three different places to take a straight line of thickness measurements. We literally just take that and stop the human from either being on the scaffolding doing that or being on a rope access doing that, and have it on a robot. So the robot drives up and carries it up. In that instance, we're obviously 100% comparable to a person. It gets the exact same
Yeah.
outcome. It's the same as you could basically think of the robot as a human's hand holding the sensor against the
Mm.
surface. But there's a number of more advanced tasks that we're probably only 80 or 90% as good as a human. Something like painting, for example. We can do a lot of the big areas on a paint job, so like the outside of a big house. The paint can get on in the large areas, but when you need to be really fine and protective around the windows, or something like that, then maybe the robot isn't quite there. There's a number of ways that we can use to overcome them, but typically, the more dexterous the task, the more perfect the task has to be, the harder it is to make a robot be good at that. So we try and choose as
Mm.
many use cases as we can that are really not needing that too much element of the human dexterity. Things like, as I say, sensor carrying, probe carrying, painting large areas, and stuff like that. So they're the tasks that we tend to focus more on.
That's really cool. That's really cool. But do you feel like over time, with a bit more innovation, um, obviously, like I don't know, with like virtual reality, if like they can control it unmanned, that sort of thing, do you feel like it could go a step further?
Yeah, so we've actually the grant that we've won is it was announced a couple of days ago. We won a grant from Innovate UK, and it was literally for that exact use cases to improve our painting. We're probably not going to do it through VR, but there's a number of different things that we can do to make our painting much more accurate. So yeah, I mean, if we were having this podcast in probably 6 months' time, we'll be significantly advanced. And I suppose that's the exciting thing about working at a startup is we all have this belief that our robot is going to be better in the future, and as long as we work hard to do it, then daily it gets better. Even from a month ago, we're way
Yeah,
better than it was, and this continuous progress and innovation, which is pretty exciting.
that is really exciting. Jack, I really want to know more about, I guess, like you didn't go to university, you mentioned before we hit record, and I'm really like eager to find out more about the journey of how you actually started it because I know you met your co-founder through school, you said.
Yeah,
Um, so I don't know, like robotics, unless your co-founder did engineering, well, you probably did. Like, how did you kind of come up with the idea, and like, how did you kind of, yeah, how did you
yeah.
come up with it?
Sure. So yeah, going way back, then my co-founder Harry, he's the technical lead on the project. My CTO. The two of us have known each other since we were about 11 years old, I think, maybe 12 years old. We went to school together, so I've known him for far too long now. Um, at school, we were kind of chalk and cheese in a way. I was the kid that was trying to sell things to my friends all the time, the classic tuck shop out of the backpack and trying to
Yeah,
sell
yeah, yeah. We've all
t-shirts and
been
all
there.
that kind of stuff. Exactly, yeah. Whereas he was the kid that was making and messing around with stuff, taking his computer apart. And one of his most famous projects is that he rebuilt a Land Rover when he was like 13 years old or something.
Wow.
So really kind of physically, mechanically, engineering minded. He went off to university, as you've rightly identified, to study engineering. And I decided that I was going to just start working. So I got a job in sales. I worked for a couple of years after school, straight out of school, in sales teams I worked at IBM for a bit, selling computers, and I moved to a drinks company, and I was selling drinks. But really, if you can sell something, you can sell anything. So I just wanted to sell stuff. And whilst I was at work, we were having a catch up over a drink, and he was kind of telling me about this idea that he'd had, which came to him when his parents asked him to paint his house. So he was basically up a ladder thinking, Jesus Christ, I've got an engineering degree, I'm up a ladder, there's got to be a better way of this happening. So he made our first ever prototype as just some fun because, as I say, he's a tinkerer, he likes making stuff. He was telling me about the prototype and over this drink that we were having, and I just kept on thinking to myself, I know you've made that for a bit of fun, but Jesus, there's got to be a market there. I was at this time working at IBM. We were selling automation packages for all sorts of crazy things, and I could see the amount of money being spent in automating. We were typically doing software into automation, customer service packages, and things like that. I was seeing how much money was being spent on automation, and then just saw that this was the perfect thing to get automated. Working at height, dangerous, time-consuming, expensive. It ticks all the boxes for something that you'd want to automate. So we didn't really think much of it. I did a bit of research. We kept on speaking, and to cut a long story short, then the market research showed that it was the perfect time to try and bring a product like that to market. And so he was studying whilst I was working, and part-time we were like in his garage making robots and testing things and talking to potential customers before we had enough data, if you like, to basically say, right, this is now actually got some traction. I quit my job. He is still on a hiatus from university, so we'll see how that ends up going. And here we are, having raised some financing for it and ended up shipping to our first customers. So that's the genesis, really.
That's really cool. That's really cool. I'd love to take a few steps back and like break down your answer a little bit. So
Sure.
when you, I guess, because one thing doing that market research and for sure, like it's something that it's so problematic, like it ticks all the boxes you said. But for me, I would do that level of research. I'd find out like there's got to be a better way here.
Mm-hmm.
But it's one thing finding that, and it's one thing, I guess, finding like knowing that there's a robot that can actually do that. Like that would be my thing. Is like, oh, it might not be possible to actually get a robot to do all these things that a human
Mm-hmm.
does.
Yeah.
Did it kind of blow you back because you didn't come from an engineering background? Did it kind of blow you back as to the actual potential that these robots can do?
To be honest, yes, and it's only recently that we've actually managed to get the robot to do the things we want it to do. The first prototypes, Harry won't berate me for saying, were terrible, and they
What could
didn't
it do?
quite work. Well, it sort of climbed, it sort of did what you wanted to do, but it would fall off the wall, or it would take too much power up, or it wasn't quite giving the elegant solution that you would want. But I guess again that's kind of part of the entrepreneur's DNA, is almost being foolish enough to believe in a future where continuous progress just never stops. And so the two of us thought we have the right skill sets between us to have a stab at it, with surrounding ourselves with even more clever people, which, by the way, is the first thing that we did, was hire 3 members of staff who are way smarter than we are. We kind of just knew that as long as if you're daily improving the product and improving the robot, then at some point you're going to be able to get to a system that does what you want to do. So yeah, especially from my point, not coming from a technical background, then there's a lot of faith you've got to put in somebody to, whilst when he's telling you, or your co-founder is telling you, yeah, this is going to be possible, there's a lot of faith you've got to give them to say, okay, we'll do it, we'll build it, I'll go and talk to the customers and you just deliver. So thankfully we managed to get past that, and yeah, as I said, the robot managed to start working. So
Jack, what were the sort of timelines with that though? Because like, what were the timelines of, I
yeah.
guess, doing that market research, knowing that there's definitely a problem there, but then obviously testing out that robot? Like, when did you start going to customers and kind of knowing that you can deliver a solution to them? Obviously, there's talking to customers, gathering the market research, and all that stuff. But when you actually go with a serious solution,
Yeah.
when does that happen? When does that happen during the lifetime?
Yeah, so there's a really good book that I'll point to right now called The Four Steps to the Epiphany. The Four Steps to the Epiphany is a book written by the same guy who did all of the lean startup stuff.
Eric
But
Rice.
it's, yeah. well, no, sorry, actually, Steve Blank, who was something to do with he was Eric Rice's professor or something. I can't remember. He's something to do with
Okay.
the lean startup thing. A
Yeah,
guy
yeah,
called
yeah.
Steve Blank. Um, 4 Steps to the Epiphany. It basically describes to you how to go from potential idea to a commercial business in, as the name suggests, 4 steps. Each step is pretty much designed on that same principle of the lean startup, of just build as little as you possibly can before you can get validation. So, like, the first thing that I was ever going to customers to show with was a PowerPoint with a couple of sketches on, and then we made this awful animation of a robot moving around a wall. And so I would then go to a customer and say, let's talk about your problems. Let's, how much money are you spending? Is this really an issue for you? Would you want it to be solved? And then you can start saying, well, here's a potential solution. And I'd get my PowerPoint up and it would be this awful sketch. And we'd talk about this sketch. And they'd go, yeah, if you could build that, then there's probably some interest in there. And then bing, you've got a little bit of validation to then say, okay, we're on the right track, so let's carry on building what we think. Or maybe you'll have another meeting where somebody even more important than the last customer will say, that presentation you showed me, don't bother building that. There's no way I could ever have any use for that. But maybe if you could solve this challenge for me, and then that kind of then impacts your product. So in a nutshell, the teachings from this book is basically, as a founder, or as a founding team, the best thing you can do is just make a set of educated guesses as to what your customers are going to want, and then you need to do the minimum possible work to get validation against your guess, and either
Yeah.
change it or carry on the same path. So, I mean, we were at least a year and a half into that process before we even could show anything physical to a customer, and then probably
Yeah.
2 and a bit years into that process before we could show something physical to a customer that actually worked. But throughout all of that time and being careful, you're then damn sure that what you're going to show them is correct. And also, you haven't spent much money to get there, because you're not just smashing loads of money and building these random products that you haven't
Yeah.
validated. So it's kind of
Exactly.
that chicken and egg situation, but building as little as you possibly
Mm.
can first. Yeah.
Yeah, and I mean that teaching and that kind of strategy goes for every startup as well. It's the kind of the plan that I'm using for the current one that I'm building. Like the listeners will know, but like I'm building a contactless business card to like innovate within the whole space of in-person networking, and we did the exact same solution where we could build the physical product, but as for the software, we kind of backpacked or like used other people's softwares to power it. So we use
Yeah.
like Contact in Bio, which is like a Linktree competitor, to build
Yeah.
it.
Yeah.
Sold a few just from that, and that was like immediate validation to know that people will pay for it. And then we're like, okay, we might as well build our own solution to make the whole process easier, and then kind of just like builds out from there. We're building a launch group as well, to kind of get more consumer feedback and like putting things through them. Like, oh, if we change the material of the card, like, would you guys like it? And some will say yes, and then we're like, we'll do it. But then we'll put out another suggestion, they'll say no, and we're like, okay, good that we shut that down early, so we didn't spend any money doing it.
Yeah.
So I mean, this whole strategy that you use for robotics, obviously the timelines are different, but I'm just illustrating that I guess
Yeah.
for any startup, the rule definitely applies. Like,
Oh yeah.
test, speak to customers, and then like build around them. I think we talked
Yeah.
about that many times on the podcast before, but really
Yeah.
good
Yeah.
to know
Exactly.
for
Yeah.
robotics it
And
works as well.
yeah, it's well, for kind of any type of hardware as well. Is the problem is you can literally be years and years and hundreds of thousands of pounds into a project if you do the build first and then they will come. You can be so much time, effort, energy, money into a project before somebody just says, actually, I don't want that product. So
Mm.
the least money you can possibly spend before getting that answer is better.
Yeah, no, 100%. So you went to the customers and gave them like the idea of a solution, kind of like with the feedback you built that solution, innovated the robot to there. And you said it was only very recently you actually had the physical product to be able to sell to them.
Yeah. I just to backtrack a little bit on that, with the the way that we approached the customers was a little bit backwards in that obviously my co-founder had the idea for a wall climbing robot, and then we started basically going to customers and asking them about it. But even then, I didn't tell the customers about our solution until probably meeting two. It would typically be meeting one would be just talk about your problem, because I had to really try hard not to um, throw my solution at them before really understanding the problem. So meeting one was typically, how much money are you spending on work at height? Is it really a problem? Do you think it's a headache? Have you tried anything to fix it? All of these sorts of things. Then meeting two, I would then start saying, well, here's a potential solution, and then kind of working around that, because that's another thing that I think it's really difficult. And there's another sound bite for your listeners. Then there's this way of interviewing people called the mum test, and the mum test is all about how do you interview somebody who could be your mum, because your mum's not going to say anything bad about you, in a way to try and get them to say bad things about you. So I definitely research the mum test in a way to structure these interviews to really get to the heart of the problem. But yeah, anyway, sorry, coming back to your question, which was, I can't remember.
Yeah, go on.
I can't remember now what the question was.
It was, I think you kind of answered it, to be honest,
Okay.
in a way. But I think the next question I really want to ask is,
sorry, it was how recently we got our products ready. So yes, we.
oh yeah. It was only quite
Yeah,
recently, right?
yeah, very recently. So throughout all of this, we would be kept on showing customers improvements, but still basically useless improvements. So it would be like, here's a robot that can climb a wall, and customers would say, great, but I'm not going to pay you for climbing a wall for me, are you? So then it would be, here's a robot that can climb a wall, and it sort of has a bit of a painting gun on it. And they'd be like, wow, that's a cool improvement, but still that painting's pretty rubbish. So
It's
I'm
not
not going to pay
commercial
you
enough.
for that, am I? Yeah,
Yeah.
exactly. And so we went through that process of kind of just, but it was just seeking extra validation, really, because at any point the customer could say, well, no, you're on the wrong track. So as long as you keep showing it to them, then you at least get the feedback. Until it was, to be honest with you, it was like the start of this year that we really got into a position where we could reliably show climbing robots doing useful things and running pilot projects. So all in all, from Harry's first ever idea to getting to the point where we've actually got a useful robot, you're probably just over 3 years, 3.5 years. So it
Wow.
can be a
Wow.
slog.
Jack, I want to ask you. Yeah. I think it's really eye-opening to me because I haven't spoken to that many, robotics entrepreneurs before. I'd love to kind of ask you the question around, we talked about the game plan of actually starting with the 4-step plan, as you mentioned before.
Yeah.
And that goes for software, hardware, goes for pretty much anything, any startup. But are there any like kind of unique, I guess, marks of a robotics startup that are more unique starting a robotics startup rather than like a software company, for instance? I know you alluded to like this is especially good for hardware, but like more specifically for robotics, obviously it took you a long time to get from the initial product to actually commercializing it now. Are there any other unique trades that, like, if people want to actually start a robotics company, how would it go about?
Yeah, I guess you touched on it already when you spoke about making your MVP by pulling together other people's software. Is that it's
Hmm.
something fairly unique about robotics in that you can't do a lot of that,
Exactly.
es- especially in the last. Well, first of all, there's been a humongous improvement in the last kind of 5 years. There's um, uh, advent and kind of accessibility of 3D printing, for example. So you can be making physical parts cheaper, quicker, and easier than ever before. But still, you have to be able to buy that 3D printer. You have to be able to then have your laptop to design the parts. You have to then be able to wait for the thing to be printed and then have enough equipment to test it
Yeah.
properly, and all of these sorts of things. So really, the mark of a successful early stage startup anyway is trying as hard as you can to not design everything from scratch, but really try and bring as much of other people's stuff together to make your prototype. So in our instance, we could have started from day one to make all of our own custom electronics. But there's adequate development boards like Raspberry Pi, which you would have heard of, or Arduino, which you can buy for £50, and then you've got a stable computer that you can run your software on off the robot. So kind of making as many of those smart choices as you can to use other people's developments to start your prototypes, the better. Because again, um, something that's pretty unique with robotics engineers specifically is engineers love to engineer, and if you let engineers engineer, they'll engineer forever. So to really kind of get a hold of I'm sure it would be lovely to design a perfect electronics package from scratch, but then you're talking way more cost, time, effort, energy, and it might go wrong anyway. So choose as many of those examples as you can. Like you said, pulling together other people's software, but in the robotics case, it's typically pulling together other people's 3D printing equipment, pulling together other people's designs, pulling together people's electronics. There's a lot of moving parts, but the more you can steal effectively from other people, the quicker you can make it happen.
Mm. Are there any sources for that though? Because I mean, the way that you spoke, obviously, like there's been innovations in the space. Like Raspberry Pi is a very good example of that, where you can kind of like plug in things from other people's like technologies. And I think software, obviously, like it's come a long way, where you can actually build like a software company very quickly. You know, you can plug in other people's technologies. Obviously, you can build an app quite quickly with, you know, drag and drop softwares and things like that.
Yeah.
Um, but is there kind of like any sources within the robotic space to be able to sort of kind of like experiment very quickly and kind of talk to customers very quickly, being able to show something that you could that like you could test between, if you know what I mean?
Yeah, a lot of these microcontrollers or single board computers have unbelievable communities around them. So whether it be Facebook groups or YouTube channels or Discord channels or whatever, then somebody typically has already solved a similar problem to what you're trying to do when it comes to the field of robotics. Somebody
Mm.
somewhere has integrated a LiDAR sensor to a Raspberry Pi and got some wheels to move so that it didn't hit an obstacle. So there's lots of people online that you can learn from these things from. Um, uh, there's a number of websites off the top of my head. There's a website called Instructables. Instructables is a really good way of, again, it's typically these kind of physical robotics, electronics based projects where they teach you how to make these things quickly. But the next step above that is then, of course, accelerators. So HausBots went through an accelerator program called HAX. HAX, HAX. HAX are the world's most active investor in hardware startups and robotics startups. Literally hundreds of startups in their portfolios all around electronics and robotics, different hardware companies, and securing investment from them was a game changer for us because we got access to their technical knowledge to kind of help us get past that hobbyist style robot, which you can knock together with Raspberry Pis and make it a lot more reliable and kind of robust. So definitely, if you're considering robotics businesses, then accelerators are going to be a massive help for you. And specifically hacks, I can't say enough good words and how impactful hacks have been to our success.
Mm. Yeah, I think it's quite funny you said that because I've had quite a few hardware companies before on the podcast, and whenever I ask them a similar question to what I just asked you, they always say accelerator programs.
Hmm.
And I feel like more so than software companies, like accelerator programs really help hardware and
Yeah,
electronics and things like that.
yeah.
Would you agree? Like, is that like, I mean,
Yeah,
just by spotting a trend?
it comes down to setup cost ultimately, right? It
Mm,
costs a lot of money to. I mean, if I'm just thinking about the equipment that we've got in our office, we've got a CNC machine which costs £3,000. We've got a number of 3D printers, probably £2,000 in 3D printers. We've got electrical testing equipment, probably another couple of grand. We've got EMC testing equipment. We've got power supplies. We've got soldering stations. We've got all of these things. Which, if you just wanted to set up your business, it's not a cheap setup cost. But that's what the
yeah.
accelerators help you with. Is hacks again? They have state-of-the-art workshop that you get access to. It's kind of like being at university. Imagine if you were an electronics student at university and you had to pay for all of the testing and manufacturing equipment at your university course. You'd never be able to do it. So it's kind of that step up, or it's kind of, again, analogous to early software businesses where you'd have to pay for your own server farm and you'd have to work out how you're going to do all these sorts of things. So accelerators are a great one for that. Maker spaces is another one. I'm not sure if you're familiar with the concept of a makerspace.
I haven't heard of any of these hardware accelerators, if I'm honest.
Okay, well, a makerspace, it's not an accelerator as opposed to just a membership to a space with this type of equipment in. So,
Oh, I see. Okay.
yeah.
Yeah.
So there's an organization called Fab Lab. Fab Lab have branches all over the country where you can pay a monthly fee to get access to that sort of equipment that I mentioned. There's one in Birmingham, which is one of the main reasons we relocated in Birmingham, called the Steam House. The Steam House is actually completely free to access, and it's got CNC machines, woodworking machines, metalworking machines, electronics equipment, and experts in all of those areas to help you. Yeah, as long as you're a business, you have to apply, obviously, but it's free, and no equity or anything like that. Steam House, that is STEAM House, Steam House. They're a fantastic organisation, and another organisation that really helped us get access to that sort of equipment. So I'd say it comes down to the startup and cost of accessing these things that you need.
That's really good. I really hope that people stay to the very end of the podcast. If you are still here, that is some amazing value that you just dropped right there. So if you are thinking of starting a robotics company, that last like 5 minutes, I think is going to be really valuable. So Jack, I'm going to wrap it up there. Thank you so much for joining me on the podcast. It's been such a pleasure having you on to talk about HausBots and just everything about robotics. Starting a robotics company, I think a lot of young people see the space as really exciting as it is. And it seems like, like for me, I've never really considered it because it's just not my area, but I know a lot of people see it as really exciting, and there is going to be a lot of innovation within that space. I feel similar to what you said, like before within software, you had to buy your own server farm and all of that stuff. I feel like hardware would probably go through the space where like you can backpack off other people as well, eventually. Yeah. So yeah, thank you so much, Jack, for coming on. How can people stay in touch with you, stay in touch with HausBots? You mentioned you got a grant, so I'm sure they'll be staying in touch with like what's going on in the future. How can people stay in touch?
So the best place really for me is LinkedIn. Jack Cornes, Cornes. I accept anybody, so just add me. Or if you really wanted to get in touch with me, then jack@housebots.com. Send me an email.
Cool. Thank you so much, Jack, for coming on again, and I'm sure we'll speak soon. Thanks so much.
No problem. Cheers, mate.